my YouTube channel, where every episode I take a physics topic and hopefully try and explain it in a simple and understandable way. Some episodes are just going to be fun physics facts, but most I'm going to try tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. So, today's episode has been specially requested by a teacher friend who says that his class are currently struggling with waves. So this is it, my first ever episode request. Let me start by telling you that waves are a form in which energy can be transferred within a medium. Waves travelling through a medium cause the particles to oscillate and vibrate. And it's the direction of these particle oscillations that make the difference between a longitudinal wave and a transverse wave. Hold on to this thought, I'm going to come back to it later. So, you have a wave that's travelling through a medium, like water, and it's then these water particles that oscillate and transfer energy between each other. It's important to know, so listen up, that the particles stay in the same place. They only transfer energy. So the rule is that all waves transfer energy, but they do not transfer matter. You can have some energy, you can have some energy, you can have some energy, you can all have some energy, but no matter. So whether it's a longitudinal or a transverse wave, they all have 5 properties that we can describe, and I'm going to talk you through them now. Aren't you lucky? To my left. I mean, it's your right, but it is still my left. So yeah, anyways, there is a standard wave diagram. The x-axis represents the distance the wave has travelled in meters. The y-axis is the displacement of the wave. So at 0, which is along the x-axis, this is the rest position. So the position of the particles when they are undisturbed and not vibrating. Therefore, everywhere else on the y-axis, the displacement is the distance the particles moved from its rest position. So the peak of the wave is the highest point of the wave above rest, and the trough is the lowest point of the wave below rest. Moving on, the amplitude is the height of the wave, which in other words is rest to crest. So this is the distance from the rest position along the x-axis to the peak or trough of the wave. And the wavelength! The wavelength is the distance between the same point on 2 adjacent waves, so like peak to peak or trough to trough. Time to mix things up. Now let's change the x-axis to time in seconds so that we can work out the other properties of the wave. The frequency is the number of complete waves passing a point per second. Frequency is measured in hertz, so 1 hertz means 1 wave per second. Hertz. Hertz, 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 hertz. Sorry, it's a fun word. So if we take my graph on the right here, there are 2 waves occurring in 1 second. So the frequency is 2 hertz. Got it? The period is the time it takes in seconds for 1 full wave to pass a certain point. So in my example here, I have 2 waves completing in 1 second, so 1 full wave must have a period of 0.5 seconds. You can remember this super easily by the equation frequency equals 1 over the period, or F equals 1 over T. And likewise, if you swap them, period equals 1 over the frequency, or T equals 1 over F. So if you know either the frequency or the period, you can always work out the other. And finally, the speed of the wave. How fast the wave is travelling, and therefore the speed at which the energy is being transferred, can be calculated using speed equals frequency multiplied by the wavelength. Remember your units! So remember, the speed will be in meters per second, the frequency will be in hertz, and the wavelength will be in meters. To make sure we can always work out one of these 3 values in this equation, please use the triangle technique I taught you in the speed equals distance over time episode. Here we are, the final stage, the difference between the longitude and the transverse wave. We've all been waiting for this. In both cases, the wave travels this way. In a transverse wave, the oscillations or vibrations are perpendicular, so 90 degrees to the direction of the energy transfer. So if the wave is travelling in this direction, the oscillations will be going up and down. Now most waves are transverse waves, so light waves, all electromagnetic waves, ripples on the water, even wiggling a slinky up and down. You get the picture. Whereas longitudinal waves are less common, and the vibrations occur in the same direction as the wave's transfer of energy. So the wave is going this way, and so are the oscillations. They're less common, but some examples are sound and ultrasound waves and shock waves. Let me summarise. Waves in which the oscillations are at right angles to the direction of the wave are transverse waves, and waves in which the vibrations are in the same direction as the wave are longitudinal waves. Boom! Nailed it! Thank you for listening! I hope you enjoyed it, and if you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.